Hey everybody, I'm going to be going over the Unit 6 reactions unit and review. Yeah, hope you enjoy. All right, so the first thing that we talked about in this unit, which feels like forever ago, was translating. So, liquid water. It's H2O. We know it's H2O. And we say that it's liquid by putting an L at the end. Okay, cool. Easy. And these are subscripted. Okay, so that looks like, so it's an L right there. Now can be electrified to yield. So it's going to yield. So we go like there, hydrogen gas, and we know that oxygen gas and hydrogen gas are both diatomics. So they're both O2s. And to say that they're gases, we're going to put a little G right here. And we know that can be electrified to yield. So this one's kind of hard to tell, but you'd basically write you'd write electricity right here. Electricity is kind of like the catalyst in that case, so it goes above the arrow. Okay, so on this one, let's see what we got here. If solid iron is exposed to a solution of lead 3 phosphate, phosphate I think is PO3. Let's check it out. You need your polyatomic for this. Phosphate is PO4. Ooh, come on, timing. All right, bam. And what's kind of crazy about lead 3 phosphate is this is going to give up a +3, and I believe the phosphate is also -3, so that should be fine right there. To yield, and also this is also a solution, so I put an aqueous right here. To yield a solution of iron 2 phosphate, and so it'd be iron 2 phosphate, PO4. I don't think I'd have you do anything this difficult on the test, but here's how I came up with this. I know that the iron is giving up 2 because it says iron 2, and phosphate over here is 3. So to be able to balance those out, I would have to have Fe3, PO4 2, and solid lead. So Pb with some solid right there. Also, it says that this is reversible, so it actually be something like that. Cool, cool. These are generally a little bit easier, but this would be solid aluminum reacts with nitrogen gas to yield aluminum nitride. Bam, bam. This right here would be aqueous rhodium, aqueous rhodium oxide decomposes into rhodium oxide, and it's solid, and oxygen gas. Cool, cool. These are just telling what type of reactions right here. This one right here would be a double replacement. This one right here would be because like single equals a double synthesis, also known as combination. This right here is the opposite of that, decomposition. Here's another double replacement. And actually this first one right here is a single replacement. My home single replacement up here. And then this right here would be a combustion. Cool, cool. Now we're gonna do the same thing, but we're gonna try and predict some products here. Okay, so this right here is a single replacement. Na is positive, so it's gonna kind of knock out the Ag. So Ag is gonna be all alone, and then it's gonna be NaCl. This right here is a combustion. So in combustion reactions, we know that water and carbon dioxide are always formed. Cool, cool. This right here, this is a special type. This is an acid base. And I can see because I have an H here and an HOH. So that's going to give me the water that's in this part right here. And then it's also going to say like, okay, we have some water going on, and then the Na and the F running it together. Oh, this is just a single thing, so it's going to have a decomposition. And it's going to decompose into its stuff, probably like H2 and O2. It could do some stuff into like water and oxygen gas, but we'll just say that one right here. This right here is another synthesis, and so it'll be like ALO, something like that. Maybe it's AL3, actually, 2. Cool, cool. All right, so now what we're going to do is the same thing, but we're going to see whether or not these reactions will proceed or be used in this table over here. So Na is going to attack the MO, and so it's going to see, like, is Na higher than Mg? Yes, it is. Na is higher than Mg. So what happens is it's going to take its spot, all right? So it looks something like that, and now Mg is all alone, and will this occur? Yes, because Na is above Mg, so it has the power to knock it out. On this one right here, I'm going to see like, hey, is F above Cl in the periodic table? In this case, yes, it is. So it will go like that. It will go yes. All right, now Cl. Is Cl above Br in the periodic table? So if I look right here, and I say is Cl above Br. So Cl is above Br, yeah, so it's MgCl2. And now Br is going to be all by itself, for a little Br. Yes, it will proceed. And now I have to see is AL above NA. I look for here. NA is up here. AL, where you at, AL? AL is below it, so no, this will not proceed. So you can say, like, if you wanted to guess what it would be like ALCL kind of thing, but it's not going to proceed, so you really don't have to spend too much time. So for single replacement reactions, I'm using this over here and the periodic table. Now this over here, double replacement, I'm going to use some solubility rules. So MgCl, so the outsides get together, so it's MgCl, and technically it's MgCl2. And in this case right here, I have Na2O, like that. Bam. Okay, so now I have to see, will these things happen? So I look over here and I'm going to say Cl. So Cl is insoluble with these, so that means it's soluble with all other things. So this is AQ. Okay, cool. So that doesn't really help us much. Cool. Let's see about this. NaO. Na is always soluble. So look at this. AQ over here, AQ over here. Will this proceed? No, it will not proceed. All right, because this is aqueous and aqueous. All right, same thing over here. I have Li and P. Li is always soluble. No help. Over here, I have K and O. K is always soluble. No help. Again, not going to happen. All right. Let's see what we have over here. On this one, I'm going to have HS, technically it's SH2 and NaCl. Now NaCl, that sodium right there, that right here, that's going to make this aqueous. But let's see if I have SH2. So S is only soluble with these, and H is not one of them. So that means it is going to be a solid. And that means, yes, it will proceed. All right. And over here, I have NaBr, NaBr. Na is always soluble, no help. And let's see here, I have FeOH. Fe, is it on here? No, but I know OH is, and it's only soluble with these, this, and this. So it is soluble. So, sorry, it's not soluble, so it's solid. So yes, it will proceed. Cool, cool. All right, so for double replacement reactions, we use this in the solubility rules. All right, last thing here is we are going to do some balancing. I have two ASs, so that doesn't really help. The sulfur may stay for the end, but here's where I'm going to start on actually is over here. I'm going to say there's 2 times 3, 6 oxygens, so that means 3 right here. Cool. Now I have 4 ASs, bam. So now I have 6 sulfurs, so that means I'm going to put 6 over here. I see I have 3 Lis. Ooh, but look at this. I have 2 nitrogen to match up with this one right here, but now I have 6 Lis over here. I'm going to start with Cl3. Sure, let's go with Cl3. I'm going to go with this over here, but what I'm going to realize pretty quickly if I go 1 here and 1 here is that I have 3 hydrogens and it needs to be in pairs. So it's kind of like, I would say like, ooh, I only want 1.5, but you can't have 1.5. So what I like to do is I put in the 1.5 and then I multiply everything by 2. So 2, 6, 2, 3. I got eyes. Ooh, we go 5 here and 2 here just to get those lined up. Now 2 PAs, 2 PAs. Easy peasy. The PO4 I'm going to treat as a single polyatomic ion. So I'm going to put a 2 over here. Gives me 2 irons. I'm going to go 2 over here. Just for 2 irons. Now I have 6 CLs. That means I'm going to have to go 3. And look at this. The 3BE already matches up with a 3BE. Easy peasy. All right. I can start with hydrogens if I want. But I'm going to go with SBs. Because I have 2 over here. I'm going to put 2 over here. Oxygens, I have 3 over here, so I'm going to go 3 over here. That means I have 6 hydrogens over here, 3 over here. The last one I'm doing is chlorine. I'm going to go with, let's see here. I'm going to put 2 here. The reason why is I want to get this to an even number, so I have 6 right here. So I have 6 chlorines on this side and 2 CRs, 2 CRs. Now here's 4 of the chlorines and here's 2 more. So if I go right here, bam, it'll work out. All right, y'all. Thanks for watching. I'll talk to you later. Peace.